Okay, Algebra 2, I've already given a lesson in class about Chapter 9.4, which focuses on multiplying and dividing rational expressions. So this video lesson is intended either for people who were absent that day, for people who are reviewing this material for the quiz on Chapter 9, or for people who are preparing for the final exam. First of all, I made a comparison between these two questions, simplify the one above and simplify the one below. In the case of the one above, remember that a straightforward way to simplify this is to start canceling. So you pull out your canceling pen, and as you go along, you're going to find that you're able to either completely cancel two terms, one above and below, or maybe reduce one in terms of its exponent, or reduce one in terms of its size, like 6 over 2 becomes 3. Sometimes you can't do any canceling, but you do the best you can in terms of canceling. In the case of this one, you're going to end up finding that that simplifies down to 3y. In the case of the question below, unfortunately, you can't do that kind of canceling. The top polynomial, the top set of terms, have, well, it is a polynomial, I guess that's the point. You're adding and or subtracting terms, and same thing with the denominator here. You can't cancel these x squared. It's not allowed to do that unless, if these had been multiplication signs, instead you would be able to cancel the x squareds. But as it is, you can't cancel individual terms within polynomials above and below. But even so, the basic idea of a rational expression, and this is a rational expression, well actually this is a rational expression as well above, but the one below, a rational expression is a set of terms above and below the dividing line, and it's considered simplified when the numerator and the denominator have no common factors, or maybe more simply said, the numerator and the denominator have nothing in common. So, as an example, a simpler example here, whoops, didn't mean to grab that. If I wanted to simplify this, I've got to figure out what the numerator and the denominator have in common that I can factor out. Well, both top and bottom, every term has an x in it, so I can factor x out. Once I've factored those x's out, I can cancel those, and I'm left with x plus 5 over x. That is as far as I can go. At this point, I cannot cancel those x's, so this is finished. This is considered simplified on the right. Look at this question. Those of you who were in class, of course, remember that I talked about this. Look at this question that a student attempted to simplify and ended up with the answer 3, and see if you can find the mistake this student made. Okay, I'm going to assume that you've hit the pause button. If you haven't, go ahead and hit the pause button, but I'm going to assume you're ready to see the answer. The student tried to cancel these 5 x's. It's exactly the same situation that I talked about on the previous slide. Let me go back. I said you can't cancel those x's. Well, likewise, you can't cancel these 5 x's. So this, 5x plus 3 over 5x, that's the finished answer. Up until then, the student had not made any mistakes. The student went from here to there perfectly appropriately, and from here to here perfectly appropriately. This is where you have to stop. Based on that, go ahead, hit the pause button, simplify this question, and when you're ready, come back. Well, actually, you know what? I will talk you through this one. I apologize. I'm forgetting that I haven't talked this through. Top polynomial here, x squared minus 4x minus 12. And bottom, both of these can be factored. When you factor them, you'll find that you can do some canceling. Whoops, didn't mean to do that. So the top factors this way, x plus 2 times x minus 6. The bottom is the difference of perfect squares. It's x minus 2 times x plus 2. Now notice that the x plus 2's can be canceled, and you're left with x minus 6 rather, over x minus 2. And that's as far as you can go. That's it in simplified form. Now, here are a couple that you can try. Hit the pause button, as I was starting to say before. When you come back, I'll show you the answers to number 4 and number 7. Okay, I'm going to assume that you've done that, and here are the answers to both. The top one can be simplified, the bottom one cannot. The bottom would be x minus 3 times x plus 3 in the numerator. Well, those don't have anything in common with 2x plus 1. You can't do any canceling. So really 7 is as far as you can go. So when the textbook says this is not possible, What they mean is it's not possible to simplify any further. 7 is fully simplified, whereas 4 can be simplified down to this answer. Now, another example. This looks a lot like the question I gave to you at the very beginning on the first slide of the video lesson. This multiplication sign in between the left and the right is not really performing any different function than the invisible multiplication sign between the 6 and the x cubed. Everything across the top is being multiplied, everything across the bottom is being multiplied. The textbook's approach to this is to say, just go ahead and multiply straight across, and that's exactly what they do. They do 5 times 6 is 30, x squared times x cubed, you add the exponents and get x to the 5th, and so on. So, as an example down here, 2 times 10 is 20, and y cubed times y is y to the 4th. Now you can do canceling, and that's what they do, and you're going to end up finding that it's 3x to the 4th over 2y. You can take a different approach if you prefer just to start canceling right away, and I'm going to show you that, but the way that is represented here, most students have found to be convenient enough and more straightforward and clearer to them. But if you prefer, you can just start canceling right away. Notice the 5 and the 10. I can cancel that 5 and turn the 10 into 2. Likewise, the 6 and the 2. I can cancel the 6 and make it 3. And you can keep going and cancel until you're finally going to find, as I've represented here, what you have left here. And my method here, with all these different colors here, is kind of cluttered. You're going to end up finding you've got this in simplified form, and you keep going. x1 times x cubed is x to the 4th, and y times 2, most people call it 2y. This is the same answer that you got on the previous slide from the textbook's approach. Either way is fine with me. I don't have a preference one over the other. Just wanted to make sure you knew about both different methods. Example 3. In this case, you can't pull out that canceling pen because you've got polynomials. Polynomial in the numerator here and polynomials in both numerator and denominator here. The only way that you're going to be able to cancel is if you factor these polynomials. So top left, I notice I can factor out 4x. And these quadratics, this one and that one, I know how to factor. So let's go ahead and do that. I factored out the 4x. I factored out this quadratic, x squared plus 2x minus 3, and made it this. As I factored this quadratic and made it this set of binomials. Now I can start doing some canceling. Notice these 4x's are going to cancel, and the x plus 3's are going to cancel. The textbook makes a change here, and this is interesting. The textbook takes a different approach. It says, notice that this 1 minus x can also be modified. 1 minus x can be thought of as negative 1 times x minus 1. If you do that, then you can go an extra step in your canceling. Okay, so as I was saying, the x plus 3's can be canceled, the 4x's can, and here's that set of canceling marks. What you're left with here is negative 1 times x minus 2. Looks like everything else is canceled. Negative 1 times x minus 2. You could have just called it negative 1 times x minus 2. I would have been fine with that. Or negative x plus 2 is the textbook's answer. Hit the pause button if you need to study this example 3. Come in with questions if you have them. I'm going to move on to the next slide. I want you to try this one. Go ahead, factor as necessary, cancel where you can, but simplify this expression. Okay, I'm going to assume that you did that, and I'm just going to jump straight to the answer. The answer is 3/10. I know it looks different than other answers I've shown you. Up until now it's been in red, but the answer is 3/10. That's what this simplifies down to. If you didn't get that, don't understand it, don't hesitate to come in and ask. Now, if you have to divide rational expressions, well, remember, if I were going to divide this, and let me actually pause here. I think this might make more sense if I show you a specific example. So if you had y over 3 divided by y over 4. Well, remember, that is a case where it makes sense to flip and multiply by the reciprocal. So then you get y over 3 times 4 over y. Now those y's cancel and you end up with 4/3. What you've done here is said, whoops, that when you're dividing one fraction by another fraction, it makes a lot more sense to multiply one fraction times the reciprocal of the other fraction. So here, in this problem here, instead of calling this fraction divided by the other, I'm going to take this fraction and multiply it times the reciprocal of this one. That's what we've done here. We've simply flipped the right side, notice. Now, like before, I can factor this numerator. This is a quadratic that I can factor. And I can factor this one on the bottom, the denominator of the right side. Go ahead and do that. Similarly, notice on the left here, I can factor the 3 out of the 3x and the negative 12. And I can start doing some canceling once I've done that. Cancel those out, and you're going to find most everything went away, and all you're left with is 5 over 3. Okay, based on that, hit the pause button. When you come back, I'm going to show you the answer to this one. Okay, I'm going to assume that you did that. I'm going to assume that you flipped the right side, factored, and found that it simplified down as shown here. X minus 2 times x plus 6 divided by 5x squared. You could have also foiled this if you'd wanted to. I wouldn't have minded if you'd called the numerator x squared plus 4x minus 12. That would have been a perfectly fine answer for the numerator as well. All right, last example. Here we've strung multiple ideas together. One fraction, one ratio, one rational expression, times this one, remember this is over 1, divided by a last one here. And this divided by one, remember you're going to have to flip that. So you end up doing what I just said. Now look for places where you can factor and simplify. Clearly you can with the denominator of the one on the right. This is going to be 3x minus 5 times 3x plus 5. That's what they've said here. And then you can start pulling out your canceling pen. You're going to find that you're going to end up from this whole mess that you had up here with just this as your final simplified answer. Hit the pause button and see if you can do the same with this question. Okay, I'm going to assume that you did that. In this case, notice the dividing happened between the first and the second of the rational expression. So, and this one was over 1. So you ended up multiplying this one times, well, this x squared plus 7x plus 12 would have been in the numerator. Here's the answer you should have ended up with, x minus 5 times x plus 4. If you had written it as a quadratic in standard form, you would have gotten x squared minus x minus 20, and that would have been just as good. That's it. That's the end of the video lesson. Don't hesitate to come in if you have any questions. I'll look forward to seeing you, and good luck on the quiz.